So in this video 11.1, we're going to define the word similar in terms of geometry. So here we go. Similarity. Figures that have the same shape and size are called congruent. We know that. But figures that have the same shape, but not necessarily the same size, are called similar. And here's a property connecting back to the previous section. If two figures are similar, they are proportional to each other. So what do I mean? Figures that have the same shape but not the same size. So just take a triangle. Let's say it's equilateral, my beautiful equilateral triangle. Okay, and I just make a bigger one. We say it has the same shape, but it's not the exact same size because maybe this is 3 and maybe this is 7. So it's equilateral, so these would all have the same 60-degree angles, same shape, but not same size. Okay, so here we go again. Think about it this way. This time I have isosceles triangles, so two of the sides are the same. And we know base angles, so these two would be the same, and these two would be the same. Oops, can't get rid of that. Sorry, I'll just make it with 2. Because actually all of these angles would be equal to each other. If this was A would be equal to X, B would be equal to Y, and C would be equal to Z. Okay. Think about like when you zoom in and out with your fingers on your phone. It's like we're just taking that small triangle and zooming out with our fingers. The angles are staying the same and the shape is staying the same, but the size is getting bigger or smaller. Okay, so now here's a problem from the quizzes we did, or worksheet, depending on which class this is. But we had to find the missing side, 36 and 12, and then we look at all these ratios and we notice something. 15, if we compare 15 divided by 5, it's equal to 3. And then if we compare the hypotenuses together, it's also 3. And we compare that missing side, it's also 3. So that's what I mean when I say similar figures are proportional. We get proportional. So we get all these ratios that are the same. And even you can even go as far as comparing other. We don't have to compare this side to this one. Obviously, we can flip the fractions over, and they're all equal to 1/3. But can we compare things like this? 15 over 36, is that the same as 5 over 12? Do you see which ones I'm comparing now? 15 and 36. Is that the same ratio as 5 to 12? Well, where's my beast calculator? Oh, no, I don't have it open. If we do, if we try to simplify this a little bit, say let's divide these by 3. Divide everything here by 3. 15 divided by 3 is 5. 36 divided by 3 is 12. So actually, these are equal. Okay, and we can compare other sides to each other. This is just one example I'll do for now. That's what I mean by proportional. So there we go. That's the same one I did. Here's another one where, let me erase that. 15, I compared the 15 over 39. So let me get a different color here. 15, compare the 15 to the 39, and then we would compare, since I did this height to the hypotenuse, if I do the same ratio here, the height to the hypotenuse, those are also going to be equal. So again, we can see if I just divide these by 3, because essentially this big triangle is 3 times the other one. Okay, so are all rectangles similar? This is a common question that should come up then. So we've got rectangles, right? We know the angles are all the same. They're all 90 degrees, but these are not similar, because I can't, if I take this smaller rectangle B, if I try to like zoom out with my fingers, I can't put it right over A. I can't make it line up exactly, because if I zoom out with my fingers, the sides are all getting bigger and bigger too. And so I can't just extend one side and make it fit right on top like that and then move it over there. I can't do that. These are not similar if that's the case. Similarity only occurs when I'm able to zoom out like on a phone and put it right over the top of something else. So, and what I mean by that again is to extend everything. So if this triangle, if I zoom out, the sides have to get bigger, but the angles stay the same. Whereas with these rectangles, if I just push this side over to make it smaller, that's breaking some of the rules of similarity. So these sides, like if I call this X and Y, these sides, these ratios would not be equal. XY would not be equal to, if I say A and B. Okay, but if I compared this one, let's say W and H, just making up some letters here, and then O and I. If I do W over O, this should be equal to H over I, if these angles are all the same. Okay, moving on. So this is our definition. We have two things that have to happen for similarity, and we use this symbol for similarity. It's kind of like the congruent symbol, only we get rid of one of those. So two polygons are similar if and only if the corresponding angles are congruent and the corresponding sides are proportional. So what we mean by corresponding is, say we have this statement, that means that this quadrilateral is similar to this other quadrilateral on the right. Corn similar to peas. And that means that this angle R is corresponding to angle A. Those would be equal. Okay, and then angle C would be corresponding to P. Those should be equal, and so on. The sides, side NR is corresponding to SA, but they're not equal, right? SA is bigger. But if I take a proportion, NR divided by SA, this should be equal to another set of corresponding sides. So if I take NC, that's corresponding to SP. Okay, those ratios would be equal. Another way you can do this is by following the letters. So NR, those are the last two letters, and notice AS are the last two letters, or SA. So that's how we know that NR and SA are corresponding to each other, because they following this map. They follow in the same order. And similarly, you can tell, like a harder case would be if I rearrange one of these. Let's say this one was kind of spun around and rotated. It could still be similar, and we would have to follow the map. And what I mean by map is this. Okay, so some questions I could ask you: are these two polygons similar? So this first one is a square, then the other one is a rectangle. Can I zoom with my fingers and make these fit over the top of each other? The answer to that is no. And one way we can prove this using all the angles are the same. So that checks off the first, or if I go back, corresponding angles are congruent. That's true, but both of these have to be true. The second thing says corresponding sides are proportional. So if I compare 12 to 12, and I set that equal here, these are not the same, clearly. But also I could compare this 12 to this 10, and they're still not equal when I compare the second 12 to the 18. So these ratios are not equal. It's pretty easy to see without even calculating anything, because 12 over 12 is 1. and 10 over 18 is not 1. And then here the numerators are both 12, so the denominators must be the same for those to be equal. Okay, so we'd say these are not similar. What about these? Actually, this time we're told that these are similar, so that's what this means. Okay, and then we're supposed to find these missing sides, x, and this missing angle. So the angle's easier. All we have to do, notice the angle is I. So I is the second letter, so it must match up with the second letter of the first one. So I is equal to m. I is congruent to m. So so 83 is congruent to y. Okay, that's the first part. And then to figure out x, we need to set up a proportion. So if I look, EG is corresponding to AL, and we can tell that EG are the last two letters, AL are also the last two letters. But that doesn't mean x equals 21. You can see just from the figure, x looks to be a little bit bigger than 21. So that should help you figure out, like, these are not the same. The angles are the same, right? This one would be 78. We don't know the other two, and we can't figure them out. But we should be able to figure out this side x. So I have to say x, class dismissed, x divided by 21 is equal to, and if I say x is on top, then I have to put 24 on top. And then I compare 24 to 18. So I'm setting up a proportion that is true. And then from here, we know how to solve these from the last section. We just cross multiply and then divide. So 24 times 21 equals 18 times x. So 24 times 21, just do that on my calculator here, is 504. And then we're going to divide by 18, and we get 28. 28 equals x. Okay. So you could have set up, this isn't the only way to set it up. We could have said, well, I'm going to put the 21 on the top, and then the x goes on the bottom. But if I do that, then the 18 must go on top because it's on the same polygon as the 21. And then the 24 has to go at the bottom. And you see when we cross multiply, we get the exact same thing. 21 times 24 and 18 times x. Okay. So that is it. Go ahead and try the quizzes, or just go have a wonderful day.